Here's number 8 from worksheet, or the problems at the back of the packet. As a young child, Billy Covert loved to go sledding. One day, young Billy, who has a mass of 38 kilograms, was awkwardly running at 3 meters per second when he jumped and landed on his 8-kilogram sled before going down a hill, as shown in the picture below. We're looking for 3 things. Part A, how fast was he traveling immediately after jumping on the sled? So that's point A. In part B, Billy then travels down the hill on his sled to point B and up to the second hill to point C. Assuming there is no friction, how fast will he be traveling at point C? And then in part C, for this part, assume that there is an average force equal to 97 newtons, force of friction. If Billy had a speed of 10 meters per second at the bottom of the hill, point B, how far did he travel between points A and B? This is a huge problem. We're just going to take this part by part. So we'll start with A, then we'll go into B, and then we'll finally go into C. So part A, we don't have to worry about a diagram that's already given. That's already shown. Let's list our give and find. We know that height at A is 9 meters. We know that the height at C is 5 meters. We know that his mass is equal to 38 kilograms. We know that his speed at A is 3, let's call him 1 and the sled 2. So V1A is 3 meters per second. And this is M1, which means with M2, the mass of the sled is 8 kilograms. It also tells us later on in the problem, we'll wait until we get to part C. So given all of that in part A, we are looking for VB in terms of, here's V1A, V2A. Let's fix that. V2A. Billy on the sled is the VB, so when they're moving. So all we need right here is momentum. It's an inelastic collision. So M1, really can't write today. M1 V1A plus M2 V2A equals M1 plus M2 VB. The sled starts from rest, so that goes to 0. M1 V1A over M1 plus M2 equals VB. So this is again how fast they're moving at point A once they hit the sled. Once he hits the sled. So mass 1, 38 kilograms times 3 meters per second divided by 38 kilograms plus 8 kilograms equals VB. And this comes out to 2.78, keeps on going, meters per second for the speed of Billy on the sled at point A. Since this is something we're solving for, we need to round it for an answer. 1 sig fig VB is about equal to 3 meters per second. But we want to store this number unrounded in the calculator. So let's go to part B. So in part B, he's on the sled, he goes down the valley, and then he goes up to part C. If we look at bar charts, and this is all assuming no friction, A, B, and C. I know you thought you were done with these forever. E, L, K, G, E, L, K, G, E, L, K, G. At A, there's no spring, he's above the base level, and he's moving. Assuming B is the base level, it's all kinetic energy at B. And then at C, he's moving, and he's above the base level. So my energy at A equals my energy at B, which equals my energy at C. I'm only concerned with A and C, so let's just keep A equal to C. EGA plus EKA equals EGC plus EKC. mg height at A plus 1/2 m VA squared equals mg height at C plus 1/2 m VC squared. These m's all disappear since they're in all terms. I'm just going to get rid of the 1/2, multiply everything by 2. So 2g height at A plus VA squared equals 2g height at C plus VC squared. This is simply an energy problem. The only unknown here is VC. So isolating that, we get 2g height at A minus 2g height at C plus VA squared equals VC squared. So 2g, just factoring this out, HA minus HC plus VA squared equals VC squared. 2 times 9.8 meters per second squared. My height at A was 9 meters minus my height at C, 5 meters, plus the number that you hopefully stored from part A. This was 2.7, keeps on going, meters per second squared equals VC squared. Multiplying this out, we get 86.1, keeps on going, meters squared per second squared equaling VC squared. Square root of that, 9.28 meters per second equals the speed at C. Again, still only one sig fig. We have to round it because this was asked for in part B of the problem. VC equals 9 meters per second. So part B was just using energy. You had to use momentum in part A and then use that number into part B. So this is applying energy and momentum. Took 2/3 of the way there. Let's now go to part C. So for part C, we're now assuming that there's work being done because there's friction. And we're only looking at A and B. So again, drawing some bar charts. This is A, this is B. ELKG, ELKG, and dissipated. Above the base level and moving at A, moving at B at the base level, but lost some energy to work. To friction. So energy at A plus work equals energy at B. Nothing cancels out here. We have kinetic energy at A plus gravitational potential energy at A plus work equals kinetic energy at B. 1/2 m VA squared plus mg height at A plus work, which is FG cosine phi, equals 1/2 m VB squared. Mass can't cancel here because it doesn't appear in this term, but the good news is I know the mass, I know VA, I know the height at A, I know the force. The only thing I don't know is the distance. I also know the V at B from part B. So let's isolate for distance. I'm going to just get rid of the 1/2. So m VA squared plus 2mg height at A plus 2 FD cosine phi equals mVB squared. Okay, getting this by itself, we get, so we'll have m VA squared plus 2mg height A minus mVB squared over negative 2f cosine phi equals D. So all I was doing was the algebra. This we have, let's see, we knew the mass. So the mass was mass of Billy, 38 kilograms, plus mass of the sled, 8 kilograms. So my total mass is 46 kilograms. It told us that the speed at B was 10.7 meters per second. We found the speed at A in part A, so we know that the speed at A is 2.7 meters per second. Everything else was the same, so that we know the height at A, and it also told us that the frictional force was equal to 97 newtons. These are givens. Because friction works against the motion, phi is 180 degrees, and looking for D. So let's put these numbers in. We have our mass, 46 kilograms. I'm just going to factor out the mass since it's in all three of those terms on the top, times 2.7, keeps on going, meters per second squared, plus 2 times 9.8 meters per second squared times 9 meters minus 10.7 meters per second squared over negative 2 times 97 newtons times the cosine of 180 degrees. And that's all equal to the distance. This comes out to 16.5, keeps on going, meters for D. Again, only one sig fig, distance is about 20 meters. So this was a long problem. There was a lot involved. Again, the only thing dealing with momentum was part A, but we had to use that and then apply it to energy, and then we added in work in part C. So just showing how it is fair game for anything from previous units to come back into play. Hopefully you didn't forget it.